Welcome to the lesson on tornado track analysis, analyzing EF scale contours and track perimeter. I'm Jim Ledoux and I will guide you through this lesson. This lesson does have objectives. The first one is using the DAT and the supplied field derived damage points on this lesson, analyze polygons that represent EF ratings using the outlined best practices, and discriminate tornado from downburst or other wind phenomenon using the comments that have been supplied by field surveyors. The second objective is using the DAT and high resolution aerial or satellite imagery, including the comments of this lesson, adjust the polygon that represents the EF ratings using the outlined best practices, and then discriminate damage associated with tornado from other severe wind. Then identify best practices in establishing the outer perimeter of the tornado. It can be difficult to determine whether the damage you see is caused by a tornado versus straight line winds. This is a major issue that I hope to provide guidance to help you resolve your questions. In cases where tornado track may be embedded in other wind damage, there is no definitive answer, but there are tips that may help you identify an outer boundary for a tornado. Many times the tornado track may be associated with stronger than EF0 wind damage, while perhaps more rarely, greater than EF0 winds extend outside of the tornado path. Other issues accompany the tornado track itself that cause variations in the appearance of path characteristics. Typically, a tornado damage path is relatively narrow relative to its length, containing more intense damage than the surroundings. Should damage extend beyond its path, that is. The damage itself should at least be non-divergent. In other words, damage not directed away from the track scribed by the vortex center. Let's see how this pans out in a walkthrough. I'll be using the Damage Assessment tool to analyze tornado damage from the Rowlett, Texas tornado that occurred on December 26, 2015. I'll start where I left off before, and that is after I've just drawn the center line of the tornado. Okay, now that we've drawn the center line for the points here along this track, we're going to go ahead and draw the perimeter of the track from start to finish. So we're going to add polygon, and we're going to make this pretty rough cut. So we're going to just draw, I'm just going to draw one outer edge all the way around, and then we'll make the fine detail adjustments later on. So we're going all the way around here. I'm adding just enough points so I can adjust them up and down the track here. But it doesn't have to be very tight, just loose. We'll make the adjustments later. I'm going to put the same event ID as I did with the center line and all the points. So that's Rowlett, Texas, 2015, December 26. And we'll put the storm date, probably the onset time of the tornado. And then next, the EF rating for the outer contour, which is going to be the EF0. So for this tornado, it is the EF0 because we don't see widespread wind damage accompanying the track. But there may be times when the outer edge of the tornado track may not be EF0. It may be something stronger than that. So it is going to be flexible depending on how widespread the wind damage was. Now we're going to go ahead and zoom in. And we're going to zoom in to the same neighborhood where I know I have a good transect with lots of points. And I'm going to adjust the outer edge to those points which I've defined as the outer edge, or let's say at least the surveyors did. And now I see them here. So I'm just going to tone down the transparency setting here so I can see the background. Now I'm going to go look for the points that have a label saying outer edge or something similar. But first I'll go ahead and set the polygon to edit mode. Okay, look at the first feature here, and in the comments I have track edge. On the other side, I have one that I click, and I don't see anything in the comment there. Another damage indicator, there's the track edge on the other side. So those are the 2 points which I'm going to go ahead and adjust the outer edge polygon to. Hit edit polygon, and now I go ahead and adjust the right side of the track. Now again, I'll go ahead and adjust the left side here. All right, and for this point here, now along the way I can find other track edges, but just for purposes of expediency, I double clicked and then get out of there, and you can see that the polygon moved. Actually, now I noticed that this edge, I just inappropriately adjusted the track to something that was unlabeled, and so I have to go back and readjust. So I go back and edit the polygon. There we go. Let's make that secondary adjustment to the proper damage indicator. And now we have that just right. So now I've got the track adjusted for the points, but now I want to go ahead and look at how to adjust the track edges for other places. And so I'm going to pull up the satellite imagery. I have it first on Worldview Panchromatic, but it's pretty neat. Over the neighborhoods, it turns out that we can actually look at the Worldview True Color because residents often put nice colorful tarps up on the roofs where they are damaged, and they show up bright and clear here on the satellite imagery. So we look around here and we can see blue tarps. If we close in, maybe some on the left, but take a look on the right. There's one there. There's another blue tarp here. And this usually indicates, somewhere between EF0 and EF1 damage. It has to be something in which the residents are interested in protecting. So if there are enough number of shingles blown off, or maybe part of a roof deck or something like that, that's where you'll see the blue tarps go up. Mostly they're blue. Sometimes there might be other colors. So we'll go ahead and see if we can make some adjustments on the right side based on that. Okay, on the left side, we see a couple blue tarps just one house over. And so this is a place where you might want to go ahead and edit the polygon. I'm going to go ahead and move it just one house to the left. So I didn't actually have to get out of edit mode. I could have just moved the image around and then start adjusting other points. So as it turns out, I'll have to go back in here. I did notice that there are a couple blue tarps outside the edge of my current polygon, so I'm going to go ahead and move it to the right. Then you can see I double clicked and then moved and got out. It looks a lot better now. To go over what I just did, I drew a rough EF0 polygon encompassing the entire tornado track. And from there, I zoomed in to make some adjustments. The first thing I did was to match the perimeter of all the field surveyor's comments citing track edge, or at least the outermost points with an EF rating, but not something that had a thunderstorm wind only. Finally, I had the convenience of high-resolution satellite imagery to adjust the outer edge to the damage that I saw. The true color data showed roof tarps quite clearly, from which I could adjust the contours, while the panchromatic imagery was even of higher resolution to reveal individual tree fall. Any imagery with a field of view for any pixel of roughly 15 centimeters or less could be useful for viewing individual damage indicators, and especially fallen trees. And once I had the outer perimeter identified, well, now we're going to go ahead and start doing individual EF rating contours. So we're going to go ahead and pretty soon transition into a walkthrough, and we'll contour the entire track. Hello again. We're going to go ahead and talk about best practices in drawing contours for other EF scale ratings, and we'll use the Rowlett, Texas tornado here for the experiment, or at least the exercise. Go ahead and pull up the Identify Edit toolbox, and we're going to add a polygon. This time, we're going to go ahead and add the EF1 contour. We'll start with the southwest part, or the start of the track, and then we'll extend up to the northeast. And along the way, we'll add waypoints so that we can use them to more quickly edit and reshape the polygon once we zoom in. So I'm clicking these waypoints up and around to the end of the track and then clicking more on the way back down. You notice that the sign there says I double click to complete the polygon. And once I'm finished, that's what I'll do right here. I'll enter in the same event ID for this contour as all the other polygons and points for this tornado track. You got to make sure that it's exactly the same event ID, right down to whether it's a hyphen or an underscore. I label it EF1, put in the storm date, and then click on it. We'll hit no for quality control, and almost immediately you see the polygon added. Now the nice thing is that I can keep drawing the polygon and scroll and move it around. But now I'm going to go ahead and zoom in a little bit here into our favorite neighborhood. And what I want to do is refine this. We'll adjust the EF1 contour to the damage points. Now I have an EF1 house off to the east, but it's isolated. And so if it is standing out and doesn't look like it belongs with the surrounding damage at the same distance from the tornado core, I might not include that. I'm going to go ahead and edit this polygon, and we'll start off on the west side. This EF1 house here looks like it was pretty representative of other EF1s, and there were enough others that I think the left side will draw just to that one. The right side, we're going to contract that towards the center line a little bit because that EF1 house is too isolated, and we want to draw to where we have sufficient numbers of EF1 houses around the same distance from the tornado center line as we think should be representative of where the EF1 contour should be. Now we could be really fancy and draw the contour to every single house and draw little circles around each EF1 house and so forth, but we ought to use discretion. So I moved the polygon and adjusted it. Now we can see it's contracted a little bit here in this transect. If I have others, I'll do the same. But instead, what I'm going to do is now draw or at least adjust the EF1 contour to the vegetation using the WorldView satellite imagery. So we'll go ahead and pull up the satellite viewer and adjust the date. So again, I'll put it up to January 6th and then make a nice big buffer and select the WorldView panchromatic. And at this point, I'll go ahead and zoom in. Again, we'll take a look at the area around the neighborhood. You can see that the center line with the debris from the RV park extending out to the north. We look to the south and you can see the disrupted RV park. And then we go down into an area with trees. And I'm going to zoom, go back and forth by fading out the satellite imagery. So here's you saw the before picture. I note the trees that were damaged, and quite a few were damaged. As I go further south, oh, you notice I turned off and on the contours by clicking on and off the non-QC'd checkbox, which allows me to look more easily into the background. Now I'm scrolling off to the southwest along the track here. My original EF1 contour covers the area, but I don't see any tree damage. Look at this tree row here. I don't see any debris or tree branches or limbs, and I should in the field. So I think something is definitely amiss here. I'm not seeing the damage I would normally associate with EF1, which would be a fairly high fraction of down trees or damaged trees. I can extend and go further south here, but what I'm going to do is I'm thinking that there's a break in the EF1 contour at least. So I'm going to retract the EF1 contour by deleting these vertices down here. And then what will happen is that the track will retract to the next set of vertices that you see. So I'll just go ahead and double click edit polygon, get out of edit mode, and then you see the EF1 contour retract. Now it's probably not retracted as much as I want it to, so I'm going to go back in and now just manually move these vertices up to where I think the EF1 contour starts based on the worldview imagery and the amount of tree fall that I see. I double click, get out of edit mode, and now you see the polygon retract a little bit more. Now at this point, I'm going to use the same worldview satellite imagery to extend a contour. I'll go further northeast along the damage track to a place north of the reservoir where the tornado crosses residential areas and then a field and another residential area. Okay, right there. I'm going to go ahead and extend the EF2 contour that we're zooming in. I'm going to go ahead and start off to the northeast here, and you can actually see the damage impacts on the houses. A lot of de-roofed houses, so this is a reasonable EF2 contour. But we go into the field to the southwest, and we'll go ahead and see about extending this polygon because there are some clues that it should be extended. So I'm looking across the field. This is the same field here used for the center line where we adjusted the track to the debris accumulation zone. So just to the southwest, I see extensive damage to houses, de-roofed houses, evidenced in the worldview, in this debris accumulation zone, which appears to be pretty intense, and then more de-roofed houses, showing EF2 strength tornadoes to the northeast. So at this point, I will go ahead and make the edits. I'll go into edit mode and extend the polygon down. I'll take both vertices. Whoops. There we go. And we'll make a further extension here in a little bit. I'm zooming in a little bit more to make sure I grab these two structures. And normally I would, hope that there were other points to extend to, but I think this is reasonable here, considering the similarities in damage that I see on both sides of the field. To recap, I avoided trying to draw a contour around every single isolated DI with more than one EF rating level of damage above its surroundings. And likewise, I didn't draw any contour the other way, around a DI with less than -1 EF rating compared to its surroundings. I'm even hesitant to draw contours of 1 EF rating for every single DI. So I prefer to draw contours around at least 2 DIs or perhaps more, and that is if one of the DIs is a tree. If the damage goes up and down by a rating, think about drawing smooth contours. Draw the outer edge of the contour with the higher DI. Let me dive into the considerations accompanying analyzing the tornado perimeter. The most important is that any debris tracers and tree fall within the tornado perimeter should be non-divergent. Yep, to illustrate this, let's go ahead and go back to the same tree fall model that we discussed in the lesson on drawing center lines. Instead, I'll now draw all the damage that's non-divergent around the center line. The tree fall for these patterns, not exhibiting a center line, may be a little bit more difficult to decipher whether or not it is divergent. Strong, slow-moving tornadoes exhibit a damage swath where the tree fall pattern may be directed opposite to the motion. However, note that none of the tree fall is directed away from the center line or convergence line. If I were to draw a tornado perimeter, then I would include all the tree fall that I see here. On the other hand, consider this. Perhaps we have no center line apparent when we consider the direction of the damage relative to the orientation of the damage swath. The weak, fast-moving tornado case that we talked about earlier also fits the rule that no damage is diverging away from the track orientation. And so really here in this case, the damage swath is entirely to the right of the vortex center. And this is the outer perimeter of the vortex or tornado that we would analyze in the DAT. Now consider the width of the damaging winds relative to the width of the flow field. You may see divergent patterns where the damage swath is wider than the tornado vortex width. The configuration may be common in QLCS tornado tracks as well as with supercells with aggressive rear flank downdrafts. In this case, you want to exclude any damage directed away from the motion of the tornado and or track center line. Divergent damage paths are unlikely to appear if the width of the damaging winds is narrower than the wind field within the vortex, however. To view an example where the damage may exist outside the tornado vortex wind field, I go back to the classic Dr. Fujita analysis of the F4 tornado that struck Windsor Locks, Connecticut in October of 1979. Fujita outlined the downbursts in blue with their attendant divergent paths. The tornadic damage is outlined in the red shaded regions. Notice that all of the damage on the left side of the track is quite clear and is well defined. It's the right side of the track that presents the problem. Downbursts embedded in the RFD merge with the tornado track in such a way that even Dr. Fujita was uncertain about where to call the damaging winds tornadic and where not to do so. Thus, he analyzed the uncertainty with a dashed perimeter. For our purposes of keeping the flow parallel or toward the tornado track orientation within the tornado swath, I reanalyze the tornado track and leave out those areas in the darker blue shading to be called thunderstorm wind. Now, there will always be zones of uncertainty, and judgment is always going to go ahead and lie with the damage survey analyst as to where to draw this distinction. Well, the question is, what if there's an EF0, or actually a greater than EF0 wind observation that exists outside the main tornado damage swath? Well, we don't want the tornado swath to cover it. So the case in point is this damage point right here, which is quite intense. Greater than EF0, trees uprooted, it's something like that. And we want to include that outside the tornado damage swath. Okay, so my initial swath is incorrect, and I'm going to have to go ahead and change it. So what I'm going to do is click on the main swath, and you can see that the outer edge of the swath turns black. In this case, the EF1 swath. And I'll go ahead and edit it. And I see one vertex there. And just to keep things simple, I'm going to go ahead and retract it so that the thunderstorm wind point, which is round, lies outside of it. Okay, so I move my cursor inside the polygon. I see the quadruple crosshair with the arrows, and I can double click to make the edit. I'm not going to go ahead and quality control it this time, but you see the polygon move. And now I'm going to do the same for the outer one. This is the EF0. And I'm going to go ahead and select it and now set it into edit mode. And I have a couple of vertices to change. I'm going to go ahead and change this one here, and I'm going to put it right on top of the EF1 contour because I think the winds are greater than EF0 all across this. But it just so happens that this one, maybe the damage direction is pointed away from the tornado track center line, and therefore is deemed not to be part of the tornado. Maybe it's a very strong rear flank downdraft gust. But we're going to go ahead and retract this contour all the way in
and lay it on top of the EF1. And then we'll go ahead and double click, make the edit, and there. So now we have this infinitely strong gradient here, which seems to be implied, but only because now we're defining the tornado swath to be inside of this thunderstorm damage. So now we're going to have to add a thunderstorm wind polygon. So go up here to my add polygon widget in the identify edit toolbox. And now I can go ahead and start drawing, and maybe I'll start drawing here where it doesn't look like I have a natural uh, change in direction or an angle in the EF0 tornado swath. And I'm going to make this a nice smooth cut here. If I don't have any other thunderstorm wind observations or any damage, then let's just make the polygon kind of adjacent to and very smooth. Let's say make it fairly nice. So I double click to add polygon. I can add the event ID. It can be similar to the tornado event ID. So in this case, it's Albany 2017-01-21. And I'm going to have to change the date. So we'll set that to 21. Let's leave it at 0. And now in the EF rating drop-down menu, we want to select thunderstorm wind. And if you want, you can add comments here as well. But we'll go ahead and add the polygon. And voila, there it is. I can make it smoother than that. I just wanted to make sure that I didn't have this unnatural kink here in the tornado polygon without an answer on the thunderstorm polygon side of things. So I made the thunderstorm polygon in such a way that it makes the overall path smooth. And if I had other observations here, other thunderstorm wind observations, or maybe the world view imagery that shows a nice swath that's divergent, well, then I can change the polygon shape to match. But anyway, there it is. All right, one final point in this lesson here about vortex swaths is what to do when you have a tornado track crossing agricultural areas. This is a problem. It's a word of caution here. We go back to the same figure that we showed before from Sko and Kogel in 2016. The last lesson we talked about center lines. Those are easy compared to trying to find a track edge. You could draw the edge to the disturbance that you see in here, but the problem is that the edge of the crop plowdowns may exist with a greater than EF0 threshold. And so the reason is that areas outside the vortex corner flow may exhibit much weaker winds at crop height than the standard 10-meter level, and thus you might wind up underestimating the rating. So a strategy, you could just connect the outer edge of the tornado track to areas where you do have DIs. So if your agricultural area is relatively small, then you could just go ahead and use whatever, the trees or houses or something like that on either side. So that's one possibility. But sometimes you have big cropland and you don't have DIs. And in this case, there really isn't a strategy because we don't have an EF scale guidance system for crops. And so in this case, you just might not be able to draw contours. As a last resort, though, that you would ever draw the outer edge of a crop blowdown because we don't know if that's truly the outer edge. You might wind up underestimating the tornado width. And now this brings us to our summary. The track analysis with surveyor points. You want to go ahead and zoom in and adjust the polygon to field surveyor comments of track edge or outermost points with the EF rating, and not the thunderstorm wind. When we go to track analysis with satellite and aerial data, there are a couple of new things here that we want to add. One is you want to use the true color to identify roof tarps and adjust the perimeter to match what you see if deemed inside the tornado track. So this often happens because roof tarps, again, are a popular tool to cover the roof up once they're damaged. And they show up very well especially in the worldview true color, and also in Landsat. True. Oh, this is very important here. You want to include visible tree damage if deemed inside the tornado track. So again, using high resolution aerial or satellite imagery. Some of the resolution should be within 15 centimeters for an instantaneous field of view if you want to pick out individual trees. So for track analysis considerations, the key thing here, you want to have the outer edge corresponding to the damage direction not pointed away from the orientation of the tornado track. Okay, this is important because if you are looking at damage pointed away, you may not be looking at tornadic flow, or at least flow involved with the vortex. It may be involved with lateral downbursts. Slow moving tornadoes. Okay, slow moving strong tornadoes often have damage direction pointed opposite to the tornado motion, but it's still non-divergent away from the tornado track. Fast-moving tornadoes may exhibit all damage directions pointed toward tornado motion. You might not see anything that's reverse, that's for sure. Now, the key thing here is you want to go ahead and draw thunderstorm damage polygons to encompass non-tornadic damage, often occurring adjacent to tornado damage. And for that area within the tornado damage, go ahead and draw EF rating contours to official damage indicators in preference to that of crop damage or other non-official damage indicators. For the outer edge of the tornado, okay, yeah, you can go ahead and draw the outer edge to the crop damage if you have no other choice. But again, if you do, the tornado width will actually be narrower than the actual winds of tornado strength. This is it for the new content on tornado track analysis, the borders. If you want to go ahead and contact me, the lesson author, my email is listed here. I also want to refer you to the Damage Assessment Toolkit site, which is located at the address shown. And there's a listserv that you can apply to if you have any questions about the DAT. Use the listserv to go ahead and ask your questions. Thank you very much and have a good day.